Um, okay. So I was on the BugBusters team, and uh, my um, my program was disease prediction. Uh, so what we built was it was just a program that detects whether a disease is prevalent in the user's body based on their lifestyle, their symptoms, and they input their age, all of those factors, and Google Gemini AI would determine whether you have it or not from 5 models we created called heart disease, arrhythmia, cancer, asthma, obesity, and diabetes.
Understood.
So what makes it special is that it's actually 5 models. It's not just one. They all work together to make predictions more accurate. And we use Streamlit for the web interface.
Okay, all right. Why Streamlit, by the way?
It was so that it would be a user-friendly experience. It's much more clean and it's nice for inputting, I think.
Okay, all right.
Okay. Uh, well, the problems that we discussed that we tried to solve with this model was many people wait extensive amount of time for checking whether they have a disease in their body, which by then it would be it would probably spread throughout their whole body, which is why with our model we created
Mm.
a tool for people to understand the health risks and help them receive health advice before the fact so that the body doesn't have the disease prevalent throughout it and catch it early on, catch the disease early on.
Understood.
So this matters heavily because chronic diseases are worldwide. So heart disease is number one killer. Cancer survival rates they increase significantly when caught earlier, and diabetes it affects a large percentage of the population, and early intervention can decrease the probability of you having like a fatal complication or just a really bad one.
Okay.
So we started with collecting our data sets from Kaggle. We use Kaggle because it's efficient, it has a lot of good data sets. Each of these contains the symptoms and the diagnoses of the patients.
All right.
In our second step, we trained our model using 5 different PY programs. So one for each chronic disease, heart, cancer, diabetes, asthma, and obesity. Each with a random forest classifier with 100 estimators.
Okay.
So we split our training data and our testing data with a 70% to 30% ratio for an efficient training data. And our accuracy was to measure the performance of the model. So before we joined them all together into one program, we had to create, uh, we had to see the accuracy of each model so that we could determine if um, they're good for the later part of it, which was creating one big program.
Okay. All right.
And finally, we used the job files for deployment so it could be easier. And our third step was building the prediction system. This was our main program called predict.py. And in this program, we implemented all the 5 models into a single web page, which we use Streamlit for it.
Okay. Why go for 5 different models too? Like you could have used one model to predict all, right? Why did you
Yeah,
go for
but
five?
we separated each one into 5 different models so that each one would have one accurate. We could see it's easier to organize and we could see it easier, so that we could determine the accuracy of each one rather than just five of them combined.
Understood. Okay.
The step four was using Google's Gemini. So Google's Gemini helped us create health advice after it determined whether the user has the disease or not. So the user gets both yes and no predictions for the disease they want to check for.
Understood.
The user interaction flow first starts with the user selecting the disease they want to check between the five chronic diseases. Um, if then after that they fill out their symptoms, their lifestyle, such as the age, their symptoms, how much they work out, etc. The AI model then analyzes the data so that it can determine whether that person has the disease or not.
Understood.
The prediction is given and advice is given, such as the dietary plan. And yeah, that's what the interaction flow looks like.
Okay.
What we used for the programming language is Python. We used five libraries: Scikit-learn for training the models, Pandas for using the data for manipulation, JobLib for deployment and training in the JobLib files, and building our UI. We use Streamlit for that because user friendly, and Google's generative AI because we wanted to communicate with Gemini to create the health advice response.
Understood.
The data sets were from Kaggle, and the tools, VS Code for Python for all the programming, and Streamlit for the interface.
Okay.
Okay. This can be used in clinics for AI pre-screening. It can be used to help you detect the disease earlier on so it doesn't spread. In the future, more chronic diseases can be implemented into this type of model to therefore then add more, determining, oh, like instead of five diseases, you could have 10 diseases and such and such. And using AI to predict diseases and also other like sicknesses like the flu or coronavirus, like things like that. And
Okay.
yeah. Okay, in conclusion, this program that we created that uses machine learning and AI to make healthcare more accessible as well as detecting diseases early on to make sure people get informed detection of their health. Uh, yeah, I guess that's it for that. Thank you.
Okay. All right. Nicely presented, by the way.
Thank you.
Do you have your interest in healthcare as well?
My interests are I like astronomy and healthcare, so
Okay.
yeah.
All right. Something that aligns with your interest then.
Yeah,
Okay. You have your demonstration ready with you?
yeah. Let me just right here. So we have the. Let me just do that. Arrhythmia. These are the five diseases you can choose from.
Mm-hmm.
I'll choose arrhythmia for now. You do your age. I'm 15, for example. And, uh oh oh 15. Okay, that's one problem. I'll say 40. I'm male. You put your type of chest pain, so whatever you're feeling, just put that. I'll put this one. Um, blood pressure, you can say you can keep that high, like 150.
Mm-hmm.
Cholesterol, yeah, we'll keep it there. Yes, I'll just go through these. Current symptoms for arrhythmia, uh, difficulty breathing. I could say 4 months. Let's say eggs, waffles, and rice. How often do you exercise? Tennis and running every other day. How many hours of sleep? You could say 7.
Okay.
One gentleman, let's say 7. Let's say no for now, and it will analyze.
Okay. All right. Simple UI, by the way. Nice.
Yeah, thank you.
Yeah. I had a word with a mentor as well, complimented you as to how interested you were in learning about this. So yeah.
Yeah.
How were the mentor-led sessions like, by the way?
Oh, they were really nice. It was short, but we covered a lot of content during those short lessons. It was
Okay. Nice.
okay. So yes, the test. This Gemini uh showed yes, the test is positive. It even detected what type of disease it could be. This is how it shows how it interpreted it. It shows the symptoms and the causes. It shows lifestyle suggestions such as your physical activity or how much consumption you have, dietary recommendations for food, and your stress management.
Okay.
Mm, yeah,
Nicely gathered suggestions. Good work on this.
thank you.
Great demonstration. By the way, what were some challenges that you faced during this?
Some challenges. One, the the asthma model. It was a little faulty at first because some of the in the data set, the categories that were used, they were a little hard to understand. So we had to clear that up. Like for example, let me go to asthma. Like before it would just say TD, it would show just the it would just show the abbreviation for these words, and it would also just it would make you input it. So we would
Okay.
have to input a number for tiredness, which is, I mean, that's a little weird. That just
Understood.
doesn't make sense.
How did you resolve that then?
We created an else if else if thing for if the input is asthma, we would use Streamlit, the Streamlit library with different instead of an input, we would have a checkbox, and
Uh,
we would also make the prompt like this instead of tiredness question mark. That's not really descriptive, so we try to
yeah,
make it simple.
got it. Understood. Can we have a brief overview of your code, by the way?
Yeah, yeah. Let me just share that. Okay.
Yeah,
Okay. This is our main code. These ones are the models we used, the individual models.
understood. All
Uh
right.
so we imported the libraries.
Mhm.
We created the Streamlit select box for the diseases. All of these data sets are we inputted them from these 4 or 5 individual models.
Mhm.
We use JobLib for each of them, and we see right here we used if user input is asthma, then we created a radio, which is just the checkbox, and it would ask for the age, all of those, like tiredness, all of those. Uh,
Understood.
Same for arrhythmia, because in arrhythmia we also encounter that same problem. But
Okay.
this is all just the arrhythmia. After that, we use an API key to configure the model and use generative AI, which is the Gemini.
Okay.
So all of these are the inputs that we or the prompts that we created for the dietary plan, like the suggestions. And we created a button for analyze my lifestyle, which is and generating content, which is just a wheel. It's just like it's just for generating the content. It's just a placeholder really. And
Mhm.
we use this try function for this also was a problem with the asthma one. There were so in each data set there was a target variable, whether it was
Mhm.
um whether it was diagnosis in cancer, target in arrhythmia. But the problem was for asthma, there were three target variables. So we had to use this try function uh, to allow for like no errors in the code. Because whenever we ran it with just this, there would be an error line 38, I believe, which is the feature. And we just use this try function to get rid of that error.
Mhm.
Yeah.
Understood.
Uh, Same with the accept.
All right.
Um, yeah, this is all just the asthma one. This is the main prompt. It's just the symptoms, these
Understood.
facts for the inputs,
Mhm.
and the response is just the what Gemini it's what Gemini generates using
Understood.
the line. And yeah, we use the Streamlit to generate the response and write it into the web interface.
Okay. All right. Understood. All right. Nicely written, by the way.
Thank you.
Okay. All right. You may stop sharing the screen.